All right. Welcome to homework help for lesson 5. Don't break the chain. Now, our first assigned problem is actually not on the first page, it's on the second. So, we're going to start off with number 4. And yeah, well, before we actually get to number 4, let's read the instructions. We always forget to do that. Okay, so the same sequence is shown in both a table and a graph. Indicate on the table where you see the rate of change of the sequence, then draw on the graph where you see the rate of change. Okay, so we're just identifying rate of changes here. All right, so let's zoom in a little bit so we can see really well what's going on. And let's go to our writing, and let's write with green without our arrows. So there we go. Okay, so I see from here, right, our first step to our second, right, we're going from 0 to 4. All right, so that is plus 4. From 4 to 8, plus 4. From 8 to 12, plus 4. All right, so we're seeing plus 4, that's our rate of change. And that's in our f of n, our function column, right? We see plus 4, plus 4, plus 4. All right, now, shown in a graph, we go over 1, up 4. So there's our plus 4. Over 1, up 4. Over 1, up 4. There it is again. All right, so we're getting our rate of change of 4 for this question. All right, so we should see our plus 4s all over the place. All right. Moving on to the set. In the next problems, you are given various types of information. Write the recursive and explicit functions for each geometric sequence. So we're writing two functions, let's underline that. Write the recursive and explicit functions for each geometric sequence. Finally, graph each sequence. All right, so then we are also going to graph, right? So then graph as well. And clearly label the axes. You'll see in a second I've actually already labeled axes to save a little bit of time on this video. But we'll get to that in a second. Let's start out with the recursive and explicit functions. All right, so recursive first. We'll do this in green, that's fine. Let's do recursive in green. All right, so our recursive, we have our first number is 2, and then 4, and then 8, and then 16. So right off the bat, I see that we're doubling each time. So we're going to say that our function f of n is just equal to the previous step, f of n minus 1, times 2. Right? And then we should also note that our first step, right, our f of 0, let's call it. Do we want to call it 0 or 1? We'll say it's our first number. So we'll say f of 1 is 2. And that gives us enough information to figure out everything in the list, everything in the function. Now let's look, and we'll do a different color. Let's do our explicit. So our explicit, we would say, all right, we're going to start at 2, and it's going to double each time, right? So if we plug in a 1, we need to get a 2, and since it's repeated multiplication, right, it's doubling each time, times 2, times 2, times 2, that tells me it's going to be exponents. So let's write an exponent with a base of 2, because that's the thing that's going to be repeated, is 2 and 2 and 2 and 2. And if we plug in a 1, we should get out 2. So if we plug a 1 in for n, we should get 2. So we can do 2 to the n, right? Because that makes, if we plug in a 1, we'll just get 2. If we plug in 2, that'll be 2 to the 2, or 2 squared, which is 4. So this will work out, all right? So that's our explicit, is 2 to the n, which I just realized I can't write it like that. I have to write f of n equals 2 to the n. There we go. F of n equals 2 to the n. All right, and that is our explicit. Now we have to go and graph this. So we go over to the next page, and way up here we go, our axes are labeled. Oh, and it says to do our recursive and our explicit here. So we can rewrite those, that's fine. Recursive is going to be, can we remember it? I believe it was f of n. Oh, it was not in orange. What am I doing? It was not in orange, it was green. Hang on, back to the green. Let's do f of n equals f of n minus 1 times 2, and then also f of 1 equals 2. That was important. All right, and then our explicit was just f of n. Nope, that wasn't quite right. F of n equals 2 to the n. All right, so now plugging in, if we have a 1, we'll do this one in orange, that's fine. If we plug in 1, we should get 2, so that'll be right here. Nope. Actually, we're going to make dots, so let's make this a little bit bigger. Maybe we'll make this twice as big. There we go. All right, so if we plug in, you know what? I want even bigger than that. 3. All right. So we plug in a 1, we're going to get 2. If we plug in a 2, we should get 4. If we plug in a 3, we should get 8, I believe. If we plug in 4, we should get 16, so that's going to be up here. And oh my goodness, it seems to be that if we plug in a 5, it is going to be way off the graph. So we'll just plug in those, right? 2, 4, 8, and 16, I believe, are all of the points we had. So we'll move on to number 7. All right. So we're looking at dots here. So let's just, I mean, we have the dots, but let's just write them as numbers because it looks like it continues on to the next page. So we want to convert it into something we can use more easily. So there are 6 dots here. Oh, it didn't write. There we go. So there are 6 dots here. Let's see, this is 3, 6, 9, 12 dots here. And then 3, 6, 9, 12, 15, 18, 21, and 24. All right, so 24 dots here. So we have 1 goes to... Watch out. Don't drop your marker. So 1 goes to 6, 2 goes to 12, 3 goes to 24. All right, so let's take that information onto the next page. Here we go. All right, so we have to remember that 1 goes to 6, 2 goes to 12, and 3 goes to 24. That was what we remembered from the previous page. All right, so this was our dots, where this was our day, and this was our dots. All right, our recursive form for this function should be f of n equals our previous, it looks like it's doubling each time, right? 6 doubles to 12, 12 doubles to 24, so that's good. All right, so it's actually the same as the previous problem, right? Where it's going to be f of n minus 1 and then times 2, right? It's going to be that same thing. And we just have to make note that f of 1 is a little bit different, right? F of 1 in this case equals 6 instead of equaling 2. So it equals 6. All right, and our explicit now, well, we're going to have our same thing, right? If our recursive said it just doubles the previous one, then we should probably have the same general thing going on, right? Where it's going to be f of n equals, they should be 2 to the n, right? There should be 2 to the n here. But if we have 2 to the 1, that should just be 2, but we need it to be 6, so it should be 3 times as big. And 2 to the 2 is 4, but we need it to be 12, so that's 3, it needs to be 3 times as big. So it should be 3 times 2 to the n. Right? And we can put the parentheses there, but we can also, because of the order of operations, we can just write it as 3 times, oh, that one's supposed to pop up, 2 to the n, right? And that'll be fine, right? That'll work for our explicit function here. All right, and we're moving over. Actually, we have some data points here, right? We have 1 and 6, 2 and 12, 3 and 24. So let's do that. Oh, I have not labeled my inputs yet, so we'll do that first. Let's go down here. We'll make this 1, 2, 3, 4, 5, 6, 7, and 8, just like the last one. And let's see. All right, so 1 needs to go to 6. That's right there. Nope. 2 has to go up to 12. That's fine. 3 needs to go to 24. And if we kept going, what would 4 go to? Well, it's doubling each time, so 4 would actually go up to 48, I believe. Right? 4 all the way up to 48 is up there. Oh, and of course it wants me to make a note. So there we go. So there seems to be some pretty steep growth happening there, which is okay. And we'll move on to the next one. 8. All right, use the middle column in each of the given tables to write the process or number patterns that relate the input to the output. Then create both a recursive and explicit function rule. All right, so let's start off with, we'll first change this back to purple, but we're not going to use it right now. We're going to use green. So first, if our input is 1 and our output is 3, it seems like we're just doing 1 times 3. Pretty straightforward. And then if 1 times 3 happened in the previous, then it seems like on the second one we had 1 times 3, right? But then in order to get to 6, we actually multiplied it by 2. So 1 times 3 times 2. And then if we're going to go from 6 up to 12, we have to take that same thing, that 1 times 3 times 2, times 2, and we actually have to double it again, times 2, right? 1 times 3 times 2 times 2 is 12, so that works out. And then for 4, it looks like we have 1 times, that didn't draw, 1 times 3 times 2 times 2 times 2. All right, so we can see there's an extra 2 each time, so that leads us to a pretty easy recursive formula, right? Where we just have f of n equals f of n minus 1, so our value is our previous value times 2, and f of 1 equals 3. So that's pretty easy. And then we'll switch for explicit. This one's going to be a little bit more challenging, but we'll do f of n equals, and now since it's the previous value being doubled, that's going to be a 2 to the n. But it looks like it's actually a little tricky because it starts at 3. And if it started at 2, we would just leave it as 2 to the n, because when n is 1, that would make it 2, so that would work out. But it's actually 3, which is 1.5 times as big, so we could write this as 1.5 times 1.5 times 2 to the n. We could write it as that. Or we could write it as 3 over 2 times 2 to the n. Now these are the same thing because 1.5 and 3 divided by 2, those are the same. Yeah, that's going to be our explicit rule. All right. We are not doing number 9. We're not doing number 10. 11. What are the instructions for these? That's probably a good thing to check. It's not on this page. It is on the previous page. All right, here we go. For the following problems, 2 points are given. All right, so we're going to be given 2 points. Good to know. 2 points are given. Plot and label. Plot and label these points on the graph. Then connect the points. Okay, so plot and label. connect them, oh man, and draw a right triangle to represent the slope and determine the slope. All right, so there's a lot going on here. There's a lot to do. And number 11, our points are E and N. But the graph that it gave us is up here. So I've copied over. E is -2, -1, and N is -2, 4. So let's use each box being just one, like normal. So let's put E on here first. So -2, -1. -2 means we go to left 2, and -1 means we go down to here. So that is our point E. And then -4, 4. 1, 2, 3, 4, but we go up 4. That's where our N is going to be. All right, so that was the first step, was add the points and label them. Plot and label them, yeah. Then connect the points and draw a right triangle for the slope. All right, so now we're drawing a right triangle. We'll do this in purple, that's going to be fine. So let's see if we can do a right triangle down. Oh, that's not very good. Let's try that one again. All right, one more try. Here we go. That one was better. Yeah, it went a little far, but that's okay. So we make it a right triangle. All right, and we're going to the left, right, 2, and up 4. So our slope is going to be 4 divided by -2. 4 divided by -2, is that right? No, it's not 4 divided by -2. It's 4 there, but it's 1 down here. All right, so it's actually not going to be 4 and -2. Sorry, 4, -2. It's actually 5 total, right? Because it's 4 above and then 1 below. So it's going to be 5 total. Aha, okay. So it is 5 divided by -2, which, oh, don't clear the canvas. That would be really bad. Which equals -5/2. Which, if we wanted the decimal version, would be -2.5. Which is fine. We can leave it as -5/2. Any of these will be correct. -5/2, 5/-2, or -2/5. All of those are going to be correct. All right, let's move on. Done with this page. Let's go over here. 13 and 14. There aren't any instructions here, so let's go back and find the instructions. Here we go. All right, find the slope. Find the slope, M, and the y-intercept, B, for each line. Then write an equation. All right, so we need to find the slope, the intercept, and write an equation, which just combines the slope and the intercept. So let's move over to number 14. All right, we need the slope. So let's find ourselves 2 points that we can use. We'll do the slope in purple, why not? All right, so this looks like 1 point up here. And this looks like another point that it crosses nicely down here. All right, so these points are at, it looks like this is -1, 3, -1, 3, and this appears to be at 0, -1. Oh, -1. All right, so in order to use these 2 points, well, we're going to say that we go down. Oh, I didn't go down quite far enough, did I? We're going to go down, it looks like 4. Right? this would be down 4, right? Because we're going down, and then we're going to go over 1. So it looks like our m would be -4, down 4, divided by 1, which is just equal to -4. So our slope is -4. Our b, right, that's our intercept. Well, our intercept we actually found as one of our points. That was the point right here, right? So our point there is actually at 0, -1. So our b, our intercept, where it crosses the x-axis, where where it crosses the y-axis, where x equals 0, happens at -1. -1. There we go. And finally, our equation, we're just going to use the slope and the intercept all together. We'll do this one in orange. Maybe not that big. We'll do it in orange, though. And that is going to be, right, remember, using our form, right, which is y equals mx plus b. So using that, we're going to plug our -4 in here, and our -1 is going to plug in there. So we end up with our equation, y equals -4x minus 1, because our b value is -1. If we add -1, that's the same as taking away 1. So that is our final equation. And let's just check to be thorough. Is there anything on the last page? There is. We have one more to do. All right, so that wasn't our final thing. We are doing one more. Here we go. All right, so first our slope. Let's figure out 2 points that'll work. We'll do this one in purple. All right, so 2 points that'll work. This looks like a point that'll work, and this looks like a point that'll work. Between these 2 points, we have to go, if we're starting here, we're going to go over 1, 2, 3, 4, 5, it looks like. And then up 1, 2, 3. All right, so over 5, up 3, which means our slope is going to be, well, it's actually, remember, it's always the change in y. It's always the vertical part on top. So it's always going to be 3 and then 5, and they're both positive numbers. So 3/5 is our slope, and our intercept, that's looking at the point where it crosses this line, our x-axis. And it looks like we actually pulled that point out, right? That point is, it looks like 0, -3. It looks like it is down 3 from the origin. So we're going to say that our intercept, this should have been in green, I apologize. Our intercept is -3, and that did not draw at all for us. So -3. And now finally our equation, remembering again, we're going to use y equals mx plus b form. Right, our y equals mx plus b form, so our 3/5 is going to go in where m is, and our -3 is going to go where the b is. So our final equation is going to be y equals 3/5 x minus 3. All right, and that is the final equation for the final problem assigned in this homework helper video.